This is the paper cooking pot or the plastic cooking pot experiment. Now for this particular version I'm going to demonstrate to you now, I'm going to use plastic. In fact, I'm going to use 2 plastic cups. These are those quite thin, just in this case see-through plastic cups, but you could try some other ones, couldn't you? So I'm going to use these, okay? These are ordinary plastic cups. As you can see, I've got some matches, I've got a small tea light candle, and I've got a little bottle of water, which I'm going to use in a minute. And this is what we're going to cook, funnily enough. So, to cook something, we of course need heat. The first thing I want to show you, I don't want you to repeat the first bit. This is just something to demonstrate to you first. So, this is what I want to do. Of course, I want you to be safe and sensible. We are using fire, obviously. Therefore, grown-up supervision, definitely, unless you're already a grown-up. Okay, so light the candle. And the first thing I'm going to do is show you what happens when we heat it up. I think you can probably figure this one out for yourself, but I want you to watch carefully, particularly the bottom of the cup. Watch it carefully. As you can see, I've melted a hole in it. Okay. And I'm sure you expected that to happen anyway, because it's very hot, of course. The temperature of a candle is extremely hot and it's easily melted through that plastic. Remember, I don't want you doing this particular version because it does actually set on fire. I don't want you doing it. We've got enough fire as it is, thank you very much. I'm going to leave that on the side. What I want you to do is take your fresh cup. So this is exactly the same cup as that one in terms of design and shape, easy to see, so nothing different about them otherwise. I want you to pour some water in. You don't need very much, just a small amount. And do the same thing, okay? Remember, be sensible. Over to you. So, this is what should happen, as long as you're sensible and careful. Watch again. You'll remember with the cup with no water in, it melted pretty quick. On this one, although there's blackness appearing, which is actually mainly soot coming up from the candle itself, because the candle, when it burns, not all of the wax burns. Some of it actually comes up as fine dust we call soot. And that's what you're seeing on the bottom of the cup now, that blackness. But I think you'll agree, not much more seems to be happening. And if we had a thermometer in that water, the temperature will be going up. Slowly, slowly, because of course it's only a small flame, so not an awful lot of heat. But it will be warming up, and in fact, if I dip my finger in now, I can even now feel it's slightly warmer. Not very warm yet, because remember, it's just a tiny flame, but it's actually beginning to get warm. I can feel it already, beginning to get warm. Obviously, if you do what I just did, make sure none of your other fingers are anywhere near the flames, of course. So just to do that, or of course you can take it right away from the flame and do that. Another thing you might want to do, which is rather more interesting, is touch the cup from underneath. You might think that's going to be boiling hot. Let's try it. Hardly warm. Of course, look, some of the soot is coming off of my fingers now. Remember what I told you about the soot? Hardly warm. Let's do it again. Isn't this interesting? Remember, when we did it with the cup with no water, it started melting through within seconds, so it must have been pretty hot. And I haven't changed that flame. That flame's still burning at the same temperature. If I immediately put it on my hand, I promise you, I hardly feel warm at all. It's a little bit warm, but not much. One more time. So where's the heat going? That's an interesting question. Where's the heat going? I think you can probably figure that out, but we'll talk about it in a minute. Amazing. So how is it that we can put a plastic cup on a flame with water in and it doesn't seem to melt the cup at all? It doesn't even seem to warm it up. Apparently not. What's going on? Well, I think some of you have probably already got a good idea about this one. When we used just the plastic cup without the water, we held it over the flame and the heat from the flame pretty much went straight into the plastic itself, raised its temperature quite high. The temperature of that candle can be as much as 800 or 900 or even 1,000 degrees Celsius. So it's really hot actually. It depends where we hold it above the flame, but it can be that hot. This plastic melts only 200 or 300 degrees. So that's why it's burnt it and melted it. Same plastic, didn't seem to do it here, did it? Certainly doesn't do it there, more to the point, because now the water, of course, is the variable, isn't it? We didn't have water there, we have here. What's so special though? What's so special about the water? Well, water needs lots of heat energy to raise its temperature. There is a scientific expression for this. We say it's got a high specific heat capacity. Don't worry about that right now. All you need to really remember is it needs lots of heat energy to raise its temperature, say by a degree, compared to maybe, say, wood or rubber, which doesn't need so much heat energy to raise its temperature by the same amount. Water needs tons of it. And so as soon as we put it over the flame, the heat from the flame was going pretty much almost straight into the water. And it wasn't even heating up the plastic in the way, which is actually quite amazing. So the heat was being sucked through in a way, right up into the water, and it was the water itself that was getting warmer and is still getting warmer right now. More amazing, of course, is I wonder how hot you could heat this. Well, believe it or not, and you shouldn't do this holding it with your fingers, but believe it or not, if we held that long enough, we would actually boil the water. We can raise that temperature so high we could boil it and it still wouldn't melt the cup. Amazing, because again, all this heat is going through into the water to raise its temperature. The only time it would actually start melting the cup is when we boil the water all away. So it's all turned into water vapour and steam and it's gone. Once that becomes dry, of course it's going to be the same as that one, and it will then start melting because the heat has nowhere else to go but the plastic, and the plastic will then melt. Remember I told you the title of this experiment was the paper cooking pot as well, because you can do it with paper. So that's a variable, I'm telling you straight away you can try. You can use paper. All I would say is, as with the plastic, use thin paper, okay? Don't use thick stuff. So thin paper cups, thin cards okay, and thin plastic cups. Isn't that amazing? So what other things could we try? Well, I've already given you one or two clues already with my explanation, but let's think of a couple of other things. What about changing the amount of water? As you can see how much we had in here. What about maybe filling the cup up? What difference might that give us? What about not using water? What about using some other household liquid? What about, say, milk, for example, or something else? I'm sure you can think of other things you can put in there instead of water. What about using more than one flame? Here, the sort of candle I'm using, of course, it'd be difficult to get another candle next to this one, but you know you can get those little thin candles like we put on party cakes and things. Thin candles, you could have 2 or 3 of those alight where all the flames do actually touch underneath. I wonder what difference that will make. Of course, if you use more flames, that means you've got to be even more careful with that, so do bear in mind. If you're changing the heat, be much more sensible, please. So we can try different amounts of heat, basically. What about different containers? Again, I've already given you some clues about that. I mentioned the paper one. Of course, there are lots of different types of plastic cup. You get some you can't see through, of course. What about those? Are they going to work? What about plastic bags? That'd be interesting. Do you think you could heat water in a plastic bag? Interesting. Paper bag. Could you heat water in a paper bag? Of course, you've got to find a piece of paper or paper bag that isn't absorbent so the water doesn't flow through. But if you can find one, try it with the paper bag as well. And see if you can think of anything else.